Welcome to Study Loop.
Use linear approximation to estimate the square root of 100.5. So what we're going to do here, we define the function f of x equals square root of x, and we're going to find the linear approximation to this function at x equals 100. That is, we're going to find the equation of the line that is the linear approximation to f at x equals 100. For that, we need a point where the line is going to pass through and the slope. In this case, the slope will be given by the derivative of the function. So the derivative of this function is derivative with respect to x of x to the 1/2, which is the exponential representation of square root of x. We know this derivative is 1/2 times x to the 1/2 minus 1. And it ends here because there is no more calculation to do because we have the basis, the variable x only. That is, we don't need to apply the chain rule. If we apply it in any way, the derivative of the base x will be 1. So in this case, it's not needed really. So we get 1/2 times x to the negative 1/2. And that's the same as 1 over 2 square root of x. So the first derivative of f at any point x is equal to 1 over 2 times square root of x. And that derivative at 100, where's the point where we're going to find the tangent line, is equal to 1 over 2 square root of 100. Square root of 100 is 10, so we get 1 over 20. And let's say this is the slope of the tangent line. Now, the tangent line of f at x equal 100 has slope 1 over 20 and passes through the point 100, f of 100. That is 100. The image of 100 is the square root of 100, so it's a point 110. So we know a point of the line, in this case a tangent line to the curve of f at x equal 100, and we know the slope. With that, we can write the equation. So the equation of the tangent line to the graph of f at x equal 100 is given by, then we know is y minus this value here, 10, equals slope, that is 1 over 20, times x minus this value here, 100. That is y equals 10 plus 1 over 20, x minus 100. That's the same expression we obtain if we develop the Taylor polynomial at 100 of degree 1. It's just that. Then we can say that the square root of x, that is the function, let's say that way, the function is approximately equal to its tangent line at 0 4x relatively close to 100. That is, when we are close to 100, this approximation is a good approximation. If we go away from that point, it's not the case. And that this means that square root of x is approximately equal to 10 plus 1 over 20 times x minus 100 for x close to 100. And now we use this idea to express the fact that square root of 100.5 is then approximately equal. And let's see that 100.5 fulfill this property because it's very close to 100. There is only a distance of 0.5. So this got to be a good approximation. So this is approximately equal to 10 plus 1 over 20 times x, which in this case is 100.5 minus 100. And we do this calculation here is 10 plus 1 over 20, 0.5. That's the same as 10 plus 0.5 over 20. That's equal to 10 plus 0.5 is 5 over 10, so it's 5 over 200. And we simplify this fraction, dividing both terms by 5, we get 1 over 40. And if we add up these two fractions, we get 401 over 40. That's the fraction we get to calculate, and that's exactly equal in this case. If we do it by hand if we want, to 10.025. That is the square root of 100.5 is approximately equal to 10.025, and that's the approximation we find using linear approximations to the function through the tangent line at 100. And if you use a calculator, we can verify that this is in fact a very good approximation.